Here's an doesn't have an issue.
Why was my mic off? Good morning, good afternoon, good day to everybody. I'm going to start again. I don't know what I said while I was somehow switched off. A couple of notices that I forgot last week. One was specifically that here where I live in the Highveld in South Africa, we are prone to severe electrical storms. And they do come up occasionally. I don't think we've got one predicted for this afternoon or this morning or this evening, whichever way you want to look at it. But when they do, having lost a number of monitors, television sets, and modems, I tend to shut down when the lightning gets severe. As a result, it might be necessary at some time in the future to cut a session short. Unfortunately, I apologize for this, but it's just nature and there's nothing we can do to control it at all. So we will always make up that time, either at stretching a following session for an additional 15 or 30 minutes maybe, or add another session in towards the end. We will still cover the material, although it might stretch out a little bit longer. So that is the notice I wanted to leave, just to let you know. Okay, Perry wasn't hearing me because that was I switched off. Summertime, remember they are in winter. Oh, summertime, yeah, it's our summertime here. That's where the storms come from. I presume that's what Marinus was trying to say. Okay, let's move on. You can't spend our entire time with pretty pictures. And we were doing a quick walkthrough of the relational RDI, Relational Development for I product. And I was just going to run through this. These were the features, the walkabout session, and then we got into a session. Now, what I did this morning, just to maybe unconfuse people somewhat, is I created a brand new workspace. I was talking about workspaces. I created a brand new one, and this is what you get when you open a clean, pristine workspace. This is what you see the first time you log in to RDI. And this is a welcome screen, which we all see in a lot of different products. And the best thing to do is to close it. This, what you are seeing here, is somebody's idea of what a good default remote system explorer perspective should be made up of. It has the remote system explorer systems. They're your remote systems. It has a team tab. It has remote system details, task tables, and whatever. Has some properties, and here's a remote scratchpad. Now, this is where you would begin. And the first thing you have to do is you have to connect your RDI to a computer. And what's nice about it is that when you click New Connection, you click the IBM I connection, and you can now build a connection to any IBMI host. Give it a local host name. It can either be a name or an IP address. Give it a connection name and a description name, and then you can make a connection to that, your development system. But, and this is the interesting part about it, you can also make connections to a lot of other IBMIs. Now, in your organization, you may have a number of systems. And RDI allows you to make connections to any system that you have an IP address for and authority to. And you can create all those connections in one single panel. And that is a fantastic feature. Notice here you've got help keeps popping up, and you can follow these help topics to read up about all sorts of different things all the time. You can click the help button, or you can right click everywhere, or you can use these little pull down arrows to give you view menus of the various things. I'm going to switch this quickly. I'm going to change my workspace back to my original workspace. It shuts down the whole of RDI and then restarts it again. And this is the RDI as it has been restarted. This is my workstation. And the important thing I want to show you here is the number of connections that I have defined within my workspace. I have my own local PC. I have my local development machine, which is here in South Africa. I have a second machine which we use for testing, which is also in South Africa. And then I have a connection via a VPN to one of our customers, Everett. So I can support them locally. Another customer, these are all customers or dealers or agents or whoever that I can actually access their machines with user IDs and passwords and VPNs if necessary, so that I have access to their systems. Now, this is very beneficial for support. And you guys, I'm telling you now, you could use this very beneficially, because you can connect to other platforms. You can look and you can see what the problems are on other systems through the RDI. Incidentally, version 9.5 has something which my version 8.5 doesn't have. 9.5 has a 5250 emulator plugin. So you can get a green screen, a 5250 green screen like that. I have to use a 5250 emulator because my version 8.5.1 does not have the emulator plugin, but you can get an emulator tab, like this object table tab here. You can get an emulator tab, so you can also have access to the IBMI directly through its 5250 interface. So I'm going to flip back again to the other workspace, something I should have prepared. And this is the new one. So once you've created a connection, one or more connections, you can then begin building your perspectives. You do a plus there, and you have a list of perspectives that are available for you to choose from. And as you can see from the list of perspectives, clearly this is not only for IBMI and RPG. You have a database development perspective, etc. There's a lot of functionality here. I use my stuff that I'm comfortable with, and other people have their own opinions, and that is why this is so difficult to give you a RDI for dummies, because it is definitely a very, very personal setup. How you work and how many pages you want, how many screens you've got in front of you. I've got 2. I would like to have 5. You know, I'd like to be surrounded by them, because I could use that space, because you can spread your RDI across there. So a lot depends on your environment and how you use it. Okay, I'm going to go back again to my own workspace. Because configuring RDI is a long process, and you don't do it all at once. It grows. As you grow into it, your configuration grows with you. So there are a couple of things that I can right-click, and you see everywhere where I click, there's a context-sensitive menu. And I can click the Connect button to make that connection to that machine. Interestingly enough, if I open up objects, these are all the object filters that I'm looking at. Some of them are predefined, others I've created for myself. These are different ways of looking at objects and source files within the connected system. However, I can also connect to more than one system at a time. I'm selling RDI, I'm not selling you on how to do it. And I'm wondering why that's taking so long to connect. There it is. You'll notice something here, and this is something you will get used to. Every RDI thing has a little icon in front of it. And these icons, if you look at this one which says Procuro, you will see that the top right-hand corner of the icon is blank. In this case, in these 3 cases, there's a little green arrow. That tells you that you are connected. You will notice that all the icons here have little green arrows. All the icons here don't. You get used to reading the icons very quickly, and that green arrow tells you whether you've got a connection or not. So setting up connections to a machine is a simple matter of a URL and a user ID and a password. And that means you can connect quite comfortably to any system that you have a physical connection with. Okay, I'm going to look at something under the Windows menu here. And there's a tab right at the bottom called Preferences. This is something that you're going to have to play with when you play with your RDI. And I would suggest even those people that are currently using it should go through this on a regular basis. These are the parameters that control how RDI behaves. And believe me, there are an enormous number of them. They control all aspects. The LPEX editor is the editor that allows you to edit your source code. And your appearance and how it behaves and what it looks like, as I said to you last time, I like the green on black. The only concession I've made against the standard SEU is all my comments are red, so they stand out easily. But I did have people working with me who had a different color for everything. Their screens looked like unbelievably colorful boxes of Smarties. That was their way of working with it. In South Africa, they're called Smarties. In America, they're M&Ms. Very colorful. And colors can mean things. People work with them. Again, the LPEX editor, its appearance, and so on and so forth. And how the parsers work, the styles of parser. These are all part and parcel of what the sorry, I'm looking for something which seems to have gone lost. Oh, I'm in the wrong machine. This is something that often happens. You get into the wrong machine, and then, of course, things come unstuck. This is my editor. I was explaining that in the Windows preferences, you can configure the look and feel of this editor. So you can color it and set it up exactly as you like. I must stress for the editor, it is SEU and PDM, but with high-powered steroids. All the things that you are used to on SEU, the before, the after, the exclude, the double copy, etc., all of those commands that you are used to from SEU and PDM still work inside this editor. But there are so many more powerful editing features that you need, again, to find the line and right-click on it and have a look at what you've got. And now this is, you clicked on a line of code within an editor, so this context menu deals with lines of code inside editors. You can select particular lines. You can select by line, by character, by rectangle. There's certain things you can do with selected lines. And so the copy functions, the move, the overlay, the delete blocks of code are so much easier and so much faster with RDI. So the editor, once you have become familiar with the editor, there is a huge amount of power in it. You have many different views of the editor. You can filter view, and you can look only at the procedures. That one didn't work because that program doesn't have procedures. You can look at the control blocks. So it shows you control statements only with a little plus sign that allows you to open that block so you can see what's in it. It makes for amazingly productive development, correction, and hunting of source. For example, that particular field, I can go up there, or I can use a Control F, and I can actually pick up all the instances of that, except I didn't find the right one. If you take any particular piece of code, you select it and filter based on that selection, you can see everywhere where that piece of code is referenced. There is so much here. I could spend days and days and days just talking about the editor and its capabilities. I can't do that here. You need to understand the productivity benefits of this, and then to begin motivating. And I seriously, you must motivate your management to purchase a license for this product. I'm not selling it. I don't get commissions, but productivity-wise, it is incredibly powerful. I'm going to take this particular piece of code. I'm going to do a Control W, which returns it all to its unfiltered state. And I'm going to show you on this code another powerful function. It's called the Outline tab. I can put it over here just so that one can see it. And I am clicked onto this source member here. And I have a structural outline showing here. I can open up, I can see the data structures that are defined within this code that I'm working on. I can, within there, I can see the fields in a data structure. The little blue dot tells me where it's used and on what line it's used. I can click on the blue dot and it will align my source and my current cursor position to that field that actually refers to it. There it is there. 110 FK, 110 FK. It shows what prototypes are used within this piece of source code. It will indicate where they are used. I can click there, and it will show me that is used in that position. If I click on the prototype itself, it will show me the definition of the prototype. I can also see what parameters this particular prototype is defining, and I can find all the places where it's accessed. And this alone is amazingly powerful in the productivity arena. For example, this one is it's actually a file record. It's got the external name of a file, it's qualified, it's based on, and you can't see the different field elements here, which has always been an irritation to me, because now I have to go and find the file and look up what fields there are in the file. In this case, I don't need to do that. I can click on that, and it will show me the fields in the file. I have the ability to switch it to defined or alphanumeric, depending on which way I want it. It shows me the name, the attributes, and also if there's an arrow, it'll show me where it's used. This shows me where the whole data structure is used. And so you have an overview of your entire program. And if you don't think, in fact, there's one of these parameters somewhere in here, which you set on if you want to automatically update this outline. Every time you make a change to the source code, it will automatically update the outline. If you don't want it to do that, you can use the refresh view, and it will refresh the outline each time. Now, if you are connected via a slow communications line at a distance to your target system, it might be better to switch that automatic update off, because it does take a little bit of time and slows down things. However, if you're on a local LAN, believe me, this is so fast that you don't even need to worry about that sort of thing. So this is a very rapid run through of the editor. Remember this, I've got this as a floating tab. I can move it around. I can even put it out onto the other side. It goes to the other window. And that's why I say 3 or 4 windows is actually quite wonderful, 3 or 4 screens, because I can move it out and it sits on my other screen. And so I've got plenty of editing space. So the outline and the editor and the functions that you have to be able to move code, copy code, delete blocks of code, make it such a formidable editor that your productivity will increase. If you get into it, your productivity will increase 100-fold very quickly, because you can search. It has an external search which allows you to search. The PDM has a search function. which allows you to search a source file or a single source member. RDI has a search function where you can specify where you want to search. I got a working set, and I actually can search my entire development, production, and testing environments for a particular component, or a particular word, or a particular field file, or opcode. And it's not slow. You can search containing text or file name patterns as well. So again, it's PDM, but with the capability beyond belief. I love this thing. I still use a green screen occasionally, because one of the things that RDI doesn't do very fast is to move source members from one source file to another. It does them one at a time, and it pops up, and you have to confirm it, and it's a bit slow. That function I use a green screen for if I've got more than one or two to do. But other than that, not much. What else can I show you quickly? What I'm going to do is, as we go through the rest of this course, and I start talking about the more technical things like building triggers, building input-output servers, how to define data, physical files, and so on and so forth, I will be using RDI all the time for examining and manipulating source members and demonstrating source members and showing you what they look like and how to write them. And you will see some of the things that can be done with RDI very quickly and very easily. If there are any questions about what it can do, you're more than happy, as we go through, to send me a question. Just prefix it by the capital letters RDI, so I know that it's in relation to what I've done with RDI and not something else. And send it through, and I will actually show you how certain things work. I do them, and I will explain what I've done and why they are so powerful. The other thing, which I will, and the last thing I'm going to rush through on RDI is, take that out of the way, I'm going to bring in the tab, which is actually the Remote Systems tab. Now, when you start with RDI, maybe what I can do here is just quickly to switch back to the earlier workspace. I'll tell you what I'm going to do first. I'm going to go to Properties, Host. I'm just going to pick up the URL that I'm using for this host. So that when I switch over to another workspace, I can create a connection. Right, new connection, IBM I, localhost is that one that I picked up. The connection name, AMW test connection, and we will say finish. And this has now created a connection for me to that same machine. If I issue the connect statement, it will also connect. There's the green arrow, which shows me that I've connected to the same machine that my other workspace was also connected to. It's very quick and very easy. But if you look here, you will see that this is the default set of objects. You get 3 commands: work with library, work with objects, work with members. You get the library list and you get the user library list. You get a set of basic commands. You can customize your commands, and you've got a basic set of commands. And so on. This is the base. Now, you use these 3 things initially to actually build your own filters for this particular connection. And having said that, I'm going to switch back. And you can see that those three there are the original plus those two. Everything else that you're looking at under these object tabs, under this objects tab, all of these plus all of these and right down, all the way down to there, are all my own customized filters that give me a view of what's on my remote system the way I want to see it. And these are filters that you can create. Either work with libraries, work with objects, work with members. Obviously, in the case of source, you will work with members. In the case of objects, you will work with objects. And in a case like this one, it gives me a list of all the libraries that start with the letters AO, because that's the filter. I can right-click, I can click Change, and it gives me all libraries star. It's a library, AO star, also Tommy star. So those two conditions will show up in this filter. Let's go down to the bottom and you will see everything is AO and then there's 3 Tommy. If you want to do something like look at source, I've got a filter here I've built called all source. And all source members. Right click on it, do a change. This is where these filters have the most incredible power. Most other filters, you can define one filter and you can't store it. You have to type it out each time. But RDI filters allow you to build up a whole series of different selections. And this one picks up stuff from different libraries. And it's picking up all files, it's picking up source members from that library. All source files, no member filter. So it's picking up every bit of source I've got in every single one of those libraries, which are my production, development, and test environments. So I can look at all my source. I can go on and on. There are so many filters here that I have built up over time when I've needed a particular thing. I'm working on something at the moment which is in my development environment. It's a ticket number 1023. And it's made up of a number of source files. This is a particular source file that contains the objects that I'm working with. Now, I can double-click on an object like this, and it will put it into the editor for editing. So there's a direct link between this source filter and the editor. I can also drag and drop it into the editor if I don't want to click more than once. What happens with RDI is you build your own environments. You create them to suit yourself. Your filters include what you want them to include to make your life comfortable. As you can see in my development environment, I have 1, 2, 3, 4, 5 different tickets with different source in them for different things that are happening within the product at the moment. And they are separated, so this one has got those source files in it. This one has got some other source files in it, and so on. There's a 1049 is the ticket number, and there are some source members that belong to that ticket. So I'm customizing by project ticket number, task number. But again, you yourselves can build anything, any form of structure that suits you. I mean, even you can change the names. I've created the names. I've got little arrows which give me where everything breaks, and it makes it look neat, and it's easy for me to work with. One thing that I must warn you about when you are creating filters: be sensible about the names you give those filters. And I will explain very carefully why that is. Because if, for example, I want to see an object list of all, here's a filter, all programs in this particular schema, I can open it this way and it will list them downwards. But what I see there is I only see the name of the program and its type. I don't see anything more. If I go back here and right-click and say Show in Table, again, here's a right-click and look at the option Show in Table. It opens up a table. And this is an object table that is similar to your PDM list. However, the big advantage of this one is I can do what PC clients can do that the green screen can't do. I can double click on that and I can sort it by attribute, or I can sort it by type, or I can sort it by name, both ascending and descending. I can sort it by last use date. So I also have a little white arrow. Watch that one. I click on it. It's a menu. It holds my previous views, so I can work with any of those. I have a subset function which allows me to subset this list that I have in front of me. Much more sophisticated subsetting than PDM. It allows me to show certain columns. I can customize those columns. I can even take this list and export it to a file. And I can define the columns I want to see by preferences. So the ability to walk around your own system, both at the source level and the object level, is so simple and so easy, and you can create filters that will give you these views in any form you like. And this is why I said right at the very, very beginning, please back up your workspace. Because every filter you add, every filter you change is part of the workspace. And if you don't back it up and you lose it, you might find that you've lost all the customization that you've done over the last 6 months. And that's very, very frustrating. Been there, done that, had a t-shirt a couple of times. So as a result, that's the number one thing to get into the habit with. Either shift it to a server, or back it up, or at least keep it safe, and preferably on a daily basis. Because I'm forever changing my filters, my selections, and everything else. The last aspect of RDI I'm going to show you today is I'm going back into my development environment here. And I'm going to look at that same list of source members that I was working on. This is, by the way, the tab is the remote systems view. So everything I see in this list, in this view, is actually on the remote system. And that is about 20 Ks from where I'm sitting at the moment. So I'm running through a local communications line, and you can see the sort of speed I'm getting is not tardy by any means. Right, every object in RDI can be clicked on and then right-clicked on and comes up with a context-sensitive menu. Be it source or another type of object, obviously the context menu will change depending on the type of object you've clicked on. It'll be appropriate to the type of object. You can open, that opens the editor. You can browse, that means you can open the editor but you can't change it. You can refresh, rename, delete, copy, move. You can use the find string in that source member to look for a string. RDI has a verifier. It's a sort of an RPG compiler. Doesn't compile, but it checks all the syntax in a source member. And I use that extensively. When I write code, I click on the verifier all the time. It's up here in this little button at the top. Page with a tick on it is the verifier. And it picks up syntax errors, which means you don't have to worry about them. They happen. I can add them to an offline project. We'll talk about that at a bit later date. I can initiate debug from here on that particular object. I can set a service entry point, and I can compare with another. So I can connect, for example, I can click on two or four members, it doesn't really matter, and compare with each other. No, I can't. In this level, I have to have two. And then I can compare them with each other. And it gives me a comparison. In this particular case, of course, they're different programs. They will be completely different. And it's a lot of rubbish, really. But it shows you where the differences are and gives you the ability to move from left to right, right to left, delete, and so on and so forth. So comparisons of existing source code to see what has changed between production and development are so easy. You just pick up the two source members and click compare. Every one of these has a context-sensitive menu. And the interesting aspect of the context-sensitive menu is this user actions entry, which appears on all the context-sensitive menus. Now, when you do this the first time with the first object, all you will see is work with user actions. And again, when you do a work with user actions, you have a choice. You can set up an object action or a member action. If you click on that, you will create a new one, new member action. Close, whoops. User actions, work with user actions, member action, option, object action. And you can create anything that operates off an IBM I command. Let me give you this one, for example. Create save file, why not? I give it a name, it's create save file. There's the command, and I can use substitution variables in the command I'm creating. These will be taken from the object that I've clicked on. I can insert a variable. I can prompt the command. And what's most fantastic about this, I can choose in which context this particular object option will be displayed. This one, create save file, has been created and will only appear if the object that I'm clicked on is a library. This means you can create hundreds of these things. But this one will only appear if the object you got clicked is a library. You can customize where you want these particular user-defined commands to be displayed. If you don't specify, it will appear everywhere. So here's a CL. Right-click on it. You will see there's no create save file here because this ain't a library. But if I go back and I open a library, right-click on the library, user actions, and you will see the create save file appears because it was defined for a library type object. So you can now begin to customize all these commands against all the objects that you've now filtered for your pleasure, so that you can operate on them all from a single right-clickable context-sensitive interface, i.e. this particular thing is a context-sensitive menu for a particular type of object available under user actions. And you customize all of that to suit yourself. And I'm sure that at this point in time, you will probably realize why I said it's very impossible for me to do this, do that, do A, do B. It just doesn't work that way because your environments will determine precisely how you are going to set this up, and your personality. I love my green screen. I will never give up my green screen. It's where I began 40 years ago. I'm not going to stop. But at least it's running in a modern IDE interface, which makes me feel a lot better about it. Okay, so that's about as much as I want to cover with the high-speed run-through RDI. I will show you later on how the debugger works and what you can do with the debug. But one thing to whet your appetite. I'm suspecting that pretty much most of you have got a different development environment from your production environment. Your production environment might be on a different LPAR, it might be different schemas, or it might be on a completely different physical IBMI. But one thing I'm fairly certain of is your production environment doesn't contain your source files. Unless if you want to debug your production environment, if something goes wrong and you want to debug your production environment, then one could, I've seen it in the past, put your source code onto the production environment in order to allow you to debug. With RDI, you don't need to do that. RDI allows you to debug an object on one system, and I'm talking about one system. If you look here, on Tembo 72 is all my source. On the AI EdgeTech machine, I have an installed object. I cannot debug that because there's no source. But with RDI, across two different machines, I can debug on AI EdgeTech using source from within my Tembo 72 development system or production system or anywhere I like, because I can specify to RDI where to get the source from in order to create a debug environment. Now this is probably a massively powerful tool because I'm fairly certain that in a lot of cases, users of your systems have reported a problem that you have been unable to duplicate in the test or the development environment. And there's nothing more frustrating than that, because you can't find the reason for a problem because you can't debug your production environment. With RDI, you can. And whether it's an interactive job or a batch job, you can still do the same debug, again, The RDI debugger is the standard interactive debug on steroids. And so you have the ability to debug an object far away from its actual source. Okay, I'm going to stop at this point. This is a question slide. So I'm pretty certain nobody has any questions. Never do at this point, simply because it's too much to take in. I would recommend, as I said, we can make some resource available to test it out. You can download the version from my mind's gone blank. Marinos, developer apps or something or other. Developer works. Thank you. The IBM's developer works. You can through there. You have to do your thing with an IBM ID, and you have to go through hoops and everything. But you can get it there. You can download it. You can install it. You have a 90-day license. And if you would like to try it out, you can try it out on your own machine. I would recommend you try it out in your development environment and not in your production environment. And if you haven't got access to an IBM I, we can probably arrange it if you would just like to poke around a little bit and see how it works. Okay, so I'm going to click the button on this, and I want to show you one of the real problems with modernization. It's the big thing that makes it difficult for those people who want to modernize to actually modernize. And bear this in mind, because you will all face it. I know that the people at Averitt have already faced it. I know that the people at Smalley Steel have already faced it. And this is basically a serious problem. Being too busy to actually upgrade to better technology. And this is something one has to work through, because the better technology will make your life easier. I warned you I was going to say this more than once. The better technology will make your life easier, which means you can do more faster with less effort. But if you refuse to go that way, nothing's going to change. So that's my comment on the subject. Right. Now, I will pause for breath and have some tea here, which I'm just going to take a sip of. If you want to ask any questions, feel free. Otherwise, in 30 seconds, I will carry on. I'm sure you're even enjoying the silence. Right, obviously no questions at this point. That's not a surprise to me. DB2, relational database, physical data store. This is the heart of your applications. It's the heart of your business. Without it, you cannot function. A lot of businesses have the attitude that says we're not IT companies. We build buses, or we build Boeings, or we build bicycles, or we make hamburgers, but we're not an IT company. Wrong. Technology has gone too far. A business cannot succeed without IT in the modern world. Mike O'Meara asks, is the license per machine? Yes, Mike, it's per seat. I'm not sure exactly what the cost is at the moment, but it is per seat. We have heard rumors that they are going to drop support for PDM in later versions. But that is, there's no stick there at all. If they do, I suspect they might drop the license, the RDI license fee, to make people, they're trying to get people to move towards it because it is a thing. Unfortunately, it is per seat. Okay. No business can survive without IT systems. Okay, going back, I have from Marinus an approximate US dollars $900 per seat is what the current license for RDI is in the States. Now, honest with you, it's a once-off, by the way. It's not annual, it's not monthly, it's once-off. $900 for a permanent license. You will recoup that in productivity inside 3 months. Once somebody has acquired the skill and is starting to use it effectively, you will recoup that type of expenditure very, very fast. So it's not horrifying as far as I'm concerned. Obviously, for people like us in South Africa where the exchange rate is terrible, it's not so great, but that we will worry about at a later date. Okay. So whether you like it or not, companies run on IT. They run on a physical data store. Their information, their history, what is owed to them, what they owe to other people, what the value of their assets are, what the cost of their production is. Everything to do with the business is stored as data in the DB2 relational database if they're running on an IBMI. DB2 relational database. And there is no way you can get away with it because the DB2 relational database is built in to the IBMI. There is no other database that operates quite like it. Most other databases you buy and you install just the same way as you install any application product. On the IBMI, you can't buy it without its DB2 database, and if you took the DB2 database out, it would not work. It would be a bunch of junk. So the DB2 relational database is integrated into the hardware of the machine in an IBMI. And as a result, it is efficient, powerful, and it can do a lot of things very quickly because it actually operates at the highest priority within the system. What we want to do with modernizing the database, and the next section is going to be talking about DB2 relational databases, how and why. The why is quite simple. The database must become the heart, the core of the system. Your entire operation must become data-centric, and the database is designed to collect, manage, and present data to whoever wants it in order to operate the company. I got things in the wrong order. The database is built into IBMI as a relational database. You can't take it out. Right, and now comes the big thing. To ensure maximum flexibility, productivity, and efficiency from a relational database, the data should be normalized to at least third normal form. Now, I'm not sure how many of you are comfortable with data normalization. Again, it's a vast topic. What I've done is I've tried to condense it and try to explain why we need third normal form and how to achieve third normal form. Once you start doing this to your own database, you may need additional information, you may need additional knowledge or additional training. But once again, the learning curve flattens out after a while, and it becomes a comfortable space to work with. The modern MVC concept we talked about separates the database from the other two components, and that's what we're after here. We want to separate, we want to extract, decouple the database from everything else in your application. That's the purpose of this exercise. We want to do this so that and we want to build that database so that the database becomes self-aware. This is not one of those science fiction things where the database rises up and takes over the world like the Terminator. But we need the database to become truly self-aware. It must know what it's prepared to accept and what it's not prepared to accept in terms of the data and its relationships. It needs to make sure from a database point of view that the data is coherent and correct and valid. This is achieved using mainly the constraints and the triggers which form part of the DB2 relational database concept. And these we are going to look into in a lot of detail, because the whole focus here must be driven towards making the database self-aware. And this is essentially a data protection device, as I think I explained on Tuesday. When I first went into this business, we had a green screen. You had to write an application, otherwise you couldn't get at your database. Nowadays, there are 346,000 different SQL clients that can access your database if they can get a connection to your system. And therefore, we have to make the database self-aware and self-managing so that only the most valid data from the acceptable sources is accepted into the database, and the data in there cannot be corrupted. Because if the data is corrupted in your database, then the business is making decisions on invalid data, which makes those decisions invalid. Okay. I'm going to introduce you to a gentleman called Dr. Edgar F. Codd. And he is a man who actually was the inventor of the DB2 relational database. He actually was employed by IBM. So if you are not happy with relational database, you're going to have to blame IBM, because IBM is responsible for the DB2 relational database and, in fact, for the whole concept of relational databases. And during his research and development on the relational model of database systems, he came up with 12 rules, which, according to him, a database must obey in order to be regarded as a true relational database. And what's very important about this, these rules are platform agnostic. These rules can be applied on any database system that manages stored data using only its relational capabilities. So Codd's 12 rules actually define what makes up a database and what you need to have in place in order to say I have a relational database at third normal form. So we're going to have time. It looks like we've got just enough time to go through COD's 12 rules. And these are, I would suggest, when you get this recording, by the way, I don't know whether you saw that the recording from Tuesday was up on the Dropbox. You've all been shared on the Dropbox, so you can download and play those recordings at will. And I would suggest that you take this recording at this point and go through, write down each of the 12 rules, laminate them and stick them up on the wall in front of your face so that you can become as familiar with them as you can possibly be, because this is really the bottom line. This is where it's all built on. And it was built in the 1970s, the early 1970s this comes from. Right. Rule number 1 is the information rule. You may, if you have a question about any one of these rules, please interrupt me. You can unmute and mute your mic, will catch my attention, and you can just type the command into the question into the chat box. Because it's probably a good idea. I'm not going to stop between each rule, but if you need clarification, please interrupt me. Rule 1, information rule. The data stored in a database, may it be user data or metadata, must be a value of some table cell. Just to clarify metadata, metadata is generally defined as data about data. So that's the difference between data and metadata. It must be a value of some table cell. Everything in a database must be stored in a table format. Now, for those of you who come from legacy systems and don't understand this newfangled terminology, a table is a file. I prefer the use of file because that's a file. You put papers in it and you store information. A table is what I sit at when I'm eating my dinner. But everybody insists it's called a table, and therefore we will also call it a table. That is information rule 1. So data is a value in a cell of a table. Rule 2, guaranteed access rule. Every single data element, i.e. that's every single data value, is guaranteed, now please listen carefully, is guaranteed to be accessible logically with a combination of table name, primary key, that's a row value of some sort, and an attribute name, which is the value of the column. No other means, such as pointers, can be used to access data. So what he's saying here with the guaranteed access rule is that you have to be able to access every cell in your database using a combination of table stroke file name, key value, and attribute name, column value, data name, field name, whatever you like to call it. He used the word attribute name. Us historical people tend to have all sorts of things. I call them field names, data element names. This is his second rule. And I'm sure that by now you can actually see where we're going with this thing. systematic treatment of null values. In the good old days when I was young, we didn't have such nonsense as null values. Unfortunately, modern systems think null values are necessary, and I actually do agree that there are some cases where null values have a value, being null. However, they create a problem within a relational database. And therefore, when you decide to build your database, you must have a systematic and uniform treatment of null values, i.e., you must have them define how you are going to treat null values must apply systematically and uniformly across your entire database. The minute you start to treat null values differently from one file to another, you're going to have a problem. Because a null value can be interpreted as one of the following. Either data is missing, data is not known, or data is not applicable. And as a result, you need to have a definite, uniform, enterprise-wide definition of how you're going to treat null values. Very important. And this is one that can be fine up to a point, and then it can turn around and bite you, and suddenly your database is not working anymore because of an inconsistent use of the null value. Active online catalog. The structured description of the entire database must be stored in an online catalog known as a data dictionary, which can be accessed by authorized users. I'm reading this slowly because I should have typed this in bold. I want to emphasize this. Users can use the same query language to access the catalog which they use to access the database itself, i.e. Active Online Catalog Rule 4 is saying you must have a complete and accurate documentation of the entire structure of your database. And now I'm going to take a pointer, put a pen, and I'm going to draw a circle around this because I can do this. AdZero Optima was designed with this particular concept in mind as a product. AdZero Optima, amongst other things, because it can do other things, but it's one of its primary functions is to apply COD's Rule 4 to create an active online catalog. In fact, what AdZero Optima does is the other way around. We create and apply the database from within AdZero Optima into your production environment. This means that there is always a clean, clear, and well-structured definition of what your database looks like. So that is the Rule 4. Now, in the early days, we used to use field reference files to sort of try and consolidate the definitions of particular data elements and keep them the same. But that was never usable in terms of the second paragraph there. You can't access it using the same query language. That was a field reference file. It had no tools to manage it. Of course, we've come a long way since then. We have triggers, we have relationships, we have all sorts of other things that make up the database. And AO provides an active online catalog for all of that stuff so that you know exactly how your database is constructed. It's one of its primary design points to apply this rule number 4. Okay, where's my arrow? I've lost my arrow. Here we go. Right, there we are. Rule 5. Comprehensive data sublanguage rule. In fact, sometimes the titles are more incomprehensible than the rule itself. A database can only be accessed using a language having linear syntax that supports data definition, data manipulation, and transaction management operations. This language can be used directly or by means of some application. That statement, this language can be used directly or by means of some application, brings both SQL, and RPG as valid languages for a relational database. RPG creates an application, it's a compiled application, and it has all the linear syntax and data definitions, etc. that are available. SQL or SQL also can be used directly, so it is also a valid language to satisfy Rule 5. But notice the statement at the bottom in red. If the database allows access to data without any help of this language, then it is considered as a violation. Now, well, I sit and think about what this means, but what it simply means is you've got to have some language that controls access to the database, and that you cannot get at that data in any other way. So that is Rule 5. These all add up to create a picture. Rule 6, your updating rule. All the views of a database, which can theoretically be updated, must also be updatable by the system. Bit exotic, this one. Views of the database imply not only the physical database, but the logical views over that database. If anything in the database can be updated, it must also be updatable by the system itself. Pretty much, people say to me, well, do we really have to say that? I don't have to say it, but COD, in his wisdom, he put this in as a rule, so I'm putting it in as a rule as well. 7, high-level insert, update, and delete rule. A database must support high-level insertion, updation, and deletion. I think that somebody made up that word, but that's how it was printed when I picked this up. This must not be limited to a single row. That is, it must also support union, intersection, and minus operations to yield sets of data records. Again, you can see the RPG and the SQL flavors in these rules. And remember, these rules were formulated way back in, I think, about 1974. Rule 8, physical data independence. This is the hardest one to implement. The data stored in a database must be independent of the applications that access the database. Any change in the physical structure of a database must not have any impact on how the data is being accessed by external applications. That's a tough one to implement. We all know what happens if you add 6 fields to a physical file. You've actually got to go and mess around with external applications sometimes. But if you follow certain specific rules about the construction of data files, the construction of logical views, you can pretty much get the physical data independence. You can tear the database away from the application so that the application does not need to be changed or is not impacted in any way by data that changes. Logical data independence. Sorry, this is the one that's most difficult to apply. The logical data in a database must be independent of its user's view, i.e. its application. Any change in logical data must not affect the applications using it. For example, if two tables are merged or one table is split into two different tables, there should be no impact or change on the user application. It is the most difficult to apply. And it happens when you begin the normalization process. You start splitting tables or merging tables, and this is where it happens. And unfortunately, I will tell you right now, experience tells me that there are techniques which we will cover to minimize the impact to the applications, but you will still have to make modifications to your applications. Once you have your database properly normalized and running sweetly, this becomes easier and easier to apply this rule. But in the beginning, you're going to have to accept application changes unless you've been doing a normalized relational database from day one. And I know there are some people out there who've been applying the normalization rules for years. So it depends on what you have. Integrity independence. And this is probably a huge key rule. A data change without the need of any change in the application. This rule makes a database independent of the front-end application and its interface. This is the purpose of modernizing your database, is to make your database independent of the application that uses it, i.e., the value in a field does not depend on the rules built into an interface program to determine whether that value is right or not. The database itself must decide whether it is prepared to accept the data or not. And it must be able to reject invalid data. And these rules must change or must be able to be modified without the need of any change to the application, i.e., if today my flag says it can only have a value of yes and no, and then the business needs me to change that so that it can be yes, no, and maybe, I should make those changes within the database itself and not need to touch the application at all. That is what this rule is about, and it's a deep one. It is the core of what modernizing a database does. It makes it self-reliant And truly, once you have a database that is self-reliant and self-aware, then your applications become truly data-centric. Everything then begins to revolve around the database, which is the way it should be. Then your different clients have a consistent base on which to build. Distribution independence. This can be achieved. There are many ways of achieving this. The end user must not be able to see that the data is distributed over various locations. Users should always get the impression that the data is located at one site only. This rule has been regarded as the foundation of distributed database systems. There are plenty of ways of achieving this. The simplest one, which is available within the IBM I operating system right at the moment, is a file type called DDM, Distributed Disk Management, or Data Management. But that's only one of all sorts of different. You can actually locate your entire database somewhere else. And so the transparency is pretty much a given these days with the advance of technology and various different methodologies for doing this. The non-subversion rule. It's red. You need to get this one firmly and solidly in place, because this is one of the primary objectives of building and decoupling the database. If a system has an interface that provides access to low-level records, then the interface must not be able to subvert the system and bypass security and integrity constraints. Now, let me translate that for you into something I'm sure you are all quite comfortable with. If a system has an interface that provides access to low-level records, we know it as DFU, DBU, or any SQL client that is out there today. These are interfaces that provide access to the low-level records. That means you can be hacked, and data can be changed in your database without the slightest trouble using a client, a SQL client that you can download off the internet. And that is why this is red. It should be in 55-point font and it should be bold. We need to protect our data. We have to apply the non-subversion rule to its nth degree to make sure that our data integrity is absolutely complete. And we can. You see, we don't want these DFUs or whatever to bypass the security and integrity constraints. Security means people who can and people who can't. Integrity means what is the data valid or not. It's as simple as that. And both of those things have to remain in place solidly and completely immovably. And the whole purpose of the roadmap that we have for modernization of the database portion of the system is designed to move towards the installation across the board of these 12 rules of EF COD, Edgar Frank COD. These drive the whole route that we are now going to go through in the next 22 sessions, I guess. Okay. There's the little question mark. Are there any questions about those rules? I can go back and I can start at the beginning again and do them all over again, or you can read them 16 times on the recording. I would like you to do that. I would like you to understand that these are the rules that actually are controlling where we're going with this whole modernization. And it's not a bad idea to make yourself quite comfortable and quite familiar with them. Okay, Ed's question, which is to everyone, so you should all be able to read it. The answer to that is yes, Ed. Check constraints, which are part of the DB2 relational database, can be changed, added and subtracted, multiplied and divided, added, and you do not need to recompile any programs accessing that field, because in fact your constraints are completely unaware and completely disinterested in the applications. The constraints, particularly the check constraint, the referential constraint, well, all of them for that matter, the primary constraint, the referential constraint, check constraint, and unique constraint, all those constraints are not interested in the application. They are interested only in the physical table itself. So if you if you change these things in any way, the programs do not need to change. Of course, if a program was used to inserting a yes into that field, and you suddenly decided to change the constraint to not allow yes, all your programs would fail, because they would try to insert a yes value into the field, and the database, via its constraint, would say you cannot put that data in. So changing the validation rules could have an impact on the application. That is definitely possible. But it's not necessary to recompile the programs unless, of course, you actually have to physically change the program in order to conform to the new rule. Table, file, row, record, cell, field. Yes, you are correct, 100%. That's the translation table. No? Marinas? Column is field. Cell, field equals column. Okay. A cell is a cell in a column. The column is actually the field, because it crosses rows. So I apologize. I get very confused with all of this. I call them files, records, and fields. And if there's somebody who really wants to get squealy on me, then I'll swap it backwards and forwards. Okay. Any other questions on the rules? Because we've got about 20 minutes, which is going to get me a chance to start talking about normalization of data. And we will pick it up next Tuesday. And I usually, when I do this, so in particular when we're getting into this type of discussion, I will roll it back a bit next Tuesday before moving forward again, so that we tend to get to, you know, it's like these TV shows, what happened in the last episode sort of thing. All right. Now, I don't expect you to read this, and I also am not going to read it to you, but it was quite deliberate. The first, I went into the internet. Internet's a wonderful thing, isn't it? Without it, we would be really lost. And I started researching normalization data. Now, I've been doing database design, normalization of data for about 30 years. I have no formal training, per se, on the theory of normalization. And once I started doing the research for this particular course, I was trying to find some way of displaying or presenting normalization in a way that made sense and that was reasonably simple. And when I started researching the internet and I started reading everybody's papers, including my friend Cod and Chris Date and Hugh Darwin, all of these people, they've all written extensively on the theories and methods of normalization. I began to realize that what I was seeing is what you're seeing on the screen in front of you. A bunch of noise. Very difficult to make sense out of, very difficult to follow, not easy to join the dots, and each author refers to the same thing in different ways, and so on and so forth. And I came to the realization that what I'd been doing instinctively for years needs to be put in a more presentable form. I couldn't possibly start extracting this information from and passing it on to you as normalizing data, because you wouldn't come back. That's really the point. I'm more nervous on the second session of these things than I am on the first, because if I get people back on the second, it's like parachute jumping. It's always the second one that's the most difficult. So I wouldn't want to chase you away by throwing the normalization theory as it is propounded by many people. I've simplified it, I've squished it, and I've created what I believe is a good basic tool to understand normalization and to keep you in line when you start normalizing. Remember my quote from Alvin Toffler, which says it's important to understand the big things when you are busy with the small things, so that the small things all go in the same direction. And this is exactly what I want to do with normalization. I want to give you a very broad brush view of what normalization actually consists of, so that when you begin the process of normalization, which you will have to do, I'm fairly certain, to a greater or lesser degree when you start modernizing, you need to make sure that everything heads in the right direction. So we will scrap this little pile of verbiage and begin with the theory of normalization, first normal form. This is where you begin. You have to look at your data. You have to look at your data tables or files. You have to look at the records and the fields within them, that is rows and columns. And you have to decide on constructing, and you must begin by putting together first normal form, or alternatively a minimal form. This is a normal form used in database normalization. A relational database table that adheres to first normal form is one that meets a certain minimum set of criteria. Now, you need, while I'm going through this and I'm explaining in detail how this thing slots together, you need to think about what your own database looks like. You need to try and relate this now to what you've got, because it might make you feel happy, it might make you feel unhappy. It'll give you a good idea of where you need to be going, where you don't need to be going. So bear in your mind your own database when you start going through this. These criteria are basically concerned with ensuring that the table is a faithful representation of a relationship and that it is free of repeating groups. Those two are key words. First normal form must represent a relationship, and it must be free of repeating groups. According to Date's definition of first normal form, a table is in first normal form if and only if it is isomorphic to some relation. You see, this is exactly what I was talking about earlier. There's a lot of theoretical phrases in here that you have to be a rocket scientist to understand. And so I interpreted and looked up and researched isomorphic to some relation. And I came up with 5 conditions that need to be satisfied. There is no top to bottom ordering to the rows, stroke records, i.e. the sequence of the record. Now remember that we are talking here about physical data files, physical files, stroke tables. We are not talking about logical files. We're talking about the physical database. The top to bottom ordering of the rows or records must have no inherent meaning, i.e. no special meaning to the top to bottom ordering of the rows. If the order of the records in the file is important, then it cannot be first normal form. Cannot. There is no left to right ordering of the columns. Exactly the same. If the left to right ordering of the column stroke fields has meaning, then it cannot be a first normal form. There are no duplicate rows, i.e. there can be no duplicate records, which implies only one thing, that the record has to have some sort of a key, and those keys cannot be duplicated. Every row-column intersection contains exactly one value from the applicable domain and nothing else. This is actually something that a lot of people miss. We used to do it a lot in the System 34, System 36 days, where you used to specify a field, and you used to specify it as an array. So it was address array, and it had 3 elements in it, i.e. the field occurred 3 times, but was defined once. And that's what this point 4 is about. That type of thing cannot happen in first normal form. You cannot have, that is known as a repeating group. You can see up the top it's in bold, and it is, the field address is a row and column intersection. It cannot contain more than one value, therefore it cannot occur more than once. So option or point 3 says that it must have a key, otherwise you can't determine whether they're duplicates or not. And point 4 says you can't have occurs or arrays within one record, because then you would have more than one value occupying a row-column intersection. And the fifth one, all columns are regular. This one does give people a lot of difficulty, i.e., rows have no hidden components, such as row IDs, object IDs, or hidden timestamps. That's what regular means, that all the components in a record are regular. No hidden row IDs, object IDs, or hidden timestamps. If your file agrees with all 5 of those points, then it can be rubber stamped as first normal form. If any one of those 5 is violated, then your file is not first normal form and cannot participate in a relational database. Can't. Because you can't move on to second normal form until you start with first normal form. So to begin with, every table must at least be first normal form. That means it must have a key. And it must be a unique key to prevent duplicate rows. It must have no dimensions or arrays in the record, and it mustn't have any irregular columns, such as hidden information. Once you can apply all 5 of those and are happy that you conform, then you can mark your file as first normal form. And that's where you have to start. Now remember, I'm talking here, and I will repeat myself again, I'm talking here about your physical data files, which means that every physical file has to have a unique key. If a physical file does not have a key, a unique key, it's not first normal form, and therefore you cannot include it into a relational database. And now I know that there are hundreds and thousands of physical data files out there that don't have keys. Because there was a period of time during which IBM on the system 38 days had a problem with performance. I think it was around 1985, if I'm not mistaken. They had a problem with performance. And they issued a recommendation that people should not put keys on the physical files in order to eliminate the performance problem, but rather to create a logical file with the unique key on the logical file. And I know that there are many systems out there. 8081, I've been updated. It was 1980-81. I know there are many systems out there that still, to this day, creating new files, subscribe to that exact parameter. That particular advisory was removed about 1.5 years later, because they issued a new release of the software which eliminated the performance problem. However, people had got into the habit of creating physical files without keys and creating a logical file with unique keys. If you have any of those physical files that do not have keys, they are not first normal form, and therefore they cannot be part of a relational database. So this brings us to task 1 for the normalization and modernization of your database is you have to identify every physical file that does not have a key, and you have to find a unique key for that database file. Before you can move any further forward, you need to find a unique key for every physical table in your database. There are tools within AO that help with this task, but it is depending on how your systems have evolved over the years. It can be no problem, or it can be a major crisis. Okay, that's what I've just been saying for the last 5 minutes. Violation of any of these conditions would mean that the table is not strictly relational, and therefore it is not in first normal form. And yes, we can argue backwards and forwards, but there will, and you will see as we move forward, why these need to apply if you want to move to the desired end result. You have to start at the beginning, and this is the beginning. Right. Examples of tables or views that would not meet this definition of first normal form are a table that lacks a unique key. Such a table will be able to accommodate duplicate rows in violation of condition 3. A view whose definition mandates that results be returned in a particular order, so that the row ordering is intrinsic and meaningful aspect of the file. This violates condition 1. The tuples in true relations are not ordered with respect to each other. This was also what, and I've highlighted this one, and in fact I've left in the hyperlink, so I can click on it, and you can see exactly what tuples means. Oh, that's a nice word, but tuple. A tuple is a finite ordered list of elements. That's what it is. I don't know why they don't call it a finite ordered list of elements instead of a tuple, but you can look it up and you can read the story behind it. The tuples in true relations are not ordered with respect to each other. A table with at least one nullable attribute. A nullable attribute would be in violation of condition 4, which requires every field to contain exactly one value from its column's domain. Now, this is where, when we were talking about null fields earlier, it got a bit, I got a bit emphatic about a consistent method of handling nulls. It should be noted, however, that this aspect of condition 4 is controversial. It marks an important departure from Codd's later vision of the relational model, which makes explicit provision for nulls. And that's the important thing. If you have a policy and a philosophy to handle nulls in a systematic manner throughout the whole database, then this does not apply, because you then know what a null value actually means. Therefore, it has a meaning. Right, first normal form summary. And this is where we're going to stop today. Each physical file table must have a unique key. A record row may not contain recurring values. Right. Those are the two things that require or that define a first normal form. I'm going to stop here. I'm not going to start on second normal form, because you can't have second normal form until you've reached first normal form. So you've got some work to do between now and Tuesday to get your database to first normal form, and then we can carry on and get it to second normal form afterwards. I don't know, if you've got 4,000 files, you better get on with it. Otherwise, you're not going to finish by Tuesday. Are there any questions at this point in time about how far we've come in terms of first normal form? Okay. You're either all in shock or furiously trying to... Okay, Kay is trying to get into the recording and get a spinning wheel, not sure why. Marina says I better warn you about my wicked sense of humor. What was so wicked about that? Oh, you mean that I didn't really mean they should actually go out and do it before Tuesday? Is that what you were getting at? Okay, we'll have to, I'm going to upload this one probably later this evening, be later on today. And yeah, okay, guys, just in case you misunderstood, I was joking about having this first normal form done by Tuesday. Is that all right, Marinas? Okay, we'll have a look at, see what your problem is getting the recording out of the Dropbox soon as possible. I'll put Marinus onto it as his punishment. All right, so no other questions. I will bid you farewell. Have a great day. And let this sink in. This is the beginning of a series of things that will give you a headache, but are worth it in the end. Thanks a lot, everybody, for your patience, and I will see you, as they say, next Tuesday. Have a great day. Ciao.